We have a topic today. Is current. It's a chapter name is current electricity. Uh, we will see the basic components which we will use in this chapter related to the current electricity and all these type of stuff. And the circuits important components are represented by some symbols in you know in circuits. When we draw circuits of electric electric circuit diagrams, so we use some kind of the diagrams to represent different things, like this is the symbol of cell. You know what cell?
Mm-hmm.
Cell. uh
Yes, that,
yeah, the source of energy, the source of potential. If you represent battery, we represent battery with the two symbols, because cell is consists of one, um like a cell is small and battery is big, so that's why we use double symbol for battery and single for cell. And next we have the symbol for the switch open. If we dislocate the wires, the switch will be open and there will be no current flowing, isn't it? If
yeah,
you cut the wire, solar, then
yeah,
there will be no flow of current,
mhm,
isn't it? Like
yeah,
I have a battery, and I have attached a bulb here,
yeah,
and this is the wire. And if you see, I have a opening here. Switch is open. So can my bulb will blow or not? Like,
um, no, it can't flow because it's blocked.
yeah. Salah, give me a second. Hello. वालेकुम सलाम नादिर भाई, क्या हाल चाल है? अल्हम्दुलिल्लाह, शुक्र अल्लाह का। नादिर भाई, एक फ्लैक्स भेजिए आपको। हाँ जी, ये एक ही फाइल है, पीपीटी में भी और उसमें भी। जो आपको फॉर्मेट अच्छा लगे उसमें निकाल दें, और वैसी ही निकालनी है जो पिछली बार निकाली थी। हाँ जी, तो ये रात को किस टाइम मिल जाएगी? चलें, ठीक है, ठीक है, बेशक मैसेज छोड़ दिएगा व्हाट्सएप पे, मैं देख लूँ। जी, अच्छी वाली वो। ओके, सो इट विल नॉट
And
बी. यस, यस,
it says there's a recording.
यस, यस, आई एम रिकॉर्डिंग इट
Oh, okay. For a reason.
फॉर maybe use of other students.
Okay.
I will share it.
Uh,
Do you need it?
yeah, maybe. Yeah,
A video? Okay, sure.
yeah, yeah.
I will
To
share.
see my progress and how I'm.
Okay, okay, sure, sure. Okay, so we have the open switch symbol, which you can see, which means there is an opening. Then the current flow will not be proceed from this portion. So that's why the bulb will not blow. Okay.
Yeah.
And when the switch will be closed like this, like this. So what will happen? You can
There'll be
see.
no current flowing through.
No, no, no. The current will flow because is it joined? The flow of current will be okay. And now the bulb will blow.
Yeah,
So this is switch closed and this is open switch. Okay.
yeah,
So this is a symbol for filament lamp or bulb.
yeah.
I had draw this one. So this is actually like this. Okay.
Mhm.
And this is fuse. This is also a part of electric circuit. It has also a current controlling factor in it. If current across, if current crosses some limit of the passage from here, then it will close the flow of current. We
Mhm.
set some limit if the current should not be exceed by 3 ampere. So what happened? So if the current exceed from 3 amperes, the current will stop flowing because of the fuse. It's like this. You know fuse?
Yeah.
They are installed in homes usually.
Mm-hmm.
Yes. Okay, LED, light emitting diode. Light emitting diode. So, Salah, these all things will come in detail. We will discuss in detail in next when it will use somewhere. So now I'm just giving a small introduction of the things. LED, light emitting diode. When it's a diode, this is a symbol of diode. Okay, Salah.
Mm-hmm.
When there are two arrows on it, it means it is LED, light emitting diode, which means when current flow through it, Salah,
Yeah.
when current flow through it, it will
Mm-hmm.
uh, it will emit light. As if from its name, you can understand light emitting diode,
Mm-hmm.
isn't it?
Yeah.
Okay. So next we have resistor, and I'm not agree with the symbol of resistor because usually in most of the books the symbol of resistor is like this. Okay,
Mm-hmm.
so we can use it this symbol. So variable resistor is just with an arrow sign in it. Resistor is something, Salah, I'm just giving a small introduction of it,
Mm-hmm.
which opposes the flow of current. Like it
Yeah.
has an opposition like in it. It's any property of it. Okay,
Mm-hmm.
so it opposes the flow of current. So it's a resistor, it's fixed resistor. There are some fixed resistor and some are variable resistor. Variable resistor are those, Salah,
Mm-hmm.
which can be which can we can change their resistance value, like whose value can be changed. Okay,
Mm-hmm.
okay. So ammeter we have. You know what is ammeter?
Me too.
Yes.
Heard of it.
Sorry.
Yeah, I know what ammeter is.
What is it? What's its purpose?
Um, it measures the current.
Yes. Okay. So we symbolize it with this symbol. And voltmeter?
Measures the volt.
Yes, measure the voltages. Okay.
Mm-hmm.
Okay.
Yeah.
Okay. And next we have diode. Okay. Just see the symbol of diode.
Yeah.
We will discuss it in detail. LDR we have. Okay.
Mm-hmm.
Light LDR, light detective is something like this. I forgot. So it basically LDR is light sensitive diode, you can say. Okay. What's its purpose for?
Uh, I don't know this one.
Have you seen street lights?
Street lights, yeah.
Street lights, light dependent resistors. Okay. It are
Mm-hmm.
light dependent resistors. So street lights have LDR in it. Have you seen any man who switch on the street light and switch off the street light?
No.
No, then how they automatically switch on and off when the night appears, at evening, and when the morning appears, the light stop. automatically. So there are light dependent resistors installed there.
mm,
Okay. So what's their purpose? So how they work, these all kind of things we will see in detail, but I will give you a short introduction. So it actually works like this. LDR is installed in the on the street lights. So when light falls at the daytime, they do not allow the current to flow. So you can see the street lights were off at the daytime.
mm,
But when evening, like Maghrib,
mm,
the intensity of light decrease. So these LDR sense it, and they found some, we fix some intensity of light that from this much amount to this much amount, it will allow. So when it reaches that amount uh, of light, so it allows the current to flow. So when it allows the current automatically to flow, the street lights automatically on after Maghrib, isn't it?
mm,
When morning appears, so again it feels the light appearing on it, a light falling on it. So when these light, when it feels the light falling on it, so it stops the current flow through it. So the street lights would be off.
mm,
Okay.
yeah.
And next we have thermistor.
It's a resistor that
Thermistor.
mainly,
Thermistor.
yeah, it's a resistor that mainly that is dependent on temperature.
Yeah, it's a heat sensitive resistor. You are right. Okay, now let's start with the first topic. Okay,
Mm-hmm.
we will all go through this chapter, always starting from the this basic topic, and which is electric current. And what is electric current, Salah?
Electric current is the current flowing through circuit,
When we say the current is flowing, then what does it mean?
passes by each point.
Sorry.
Current is flowing is when the current passes by each point throughout the circuit.
uh yeah, the current passing. But when we say that in this wire the current is passing, the current is flowing, then what does it mean? It means that the electric charges are flowing, and the flow of electric charge is known as current. The flow of electric charge through any cross-sectional area is called as
Cur-
current.
Current.
But what is the thing which motivate the charge to flow? So that's the
Uh,
potential difference provided by battery or some source, which we will see potential difference in detail. This is the driving force which pushes the charge to flow in the circuit. Okay.
mm-hmm.
So the current is defined as the rate of flow of charges. The rate of
Flow charge.
flow of charges is known as current. Okay.
Yeah.
So we symbolized current by I, and its unit is amperes. Units is amperes. Okay.
Mhm.
And we symbolized charge by Q, and its symbol is coulombs. And its unit is coulomb. What?
Mm,
It's a name of scientist, Coulomb, Charles Coulomb. And ampere is also the name of scientist.
yeah,
Okay.
yeah.
So, a battery. The potential difference is the driving force that pushes the charge around the circuit. That is what I told. Resistance is anything that slows down the flow of charge. We will see in the detail what is a resistance. Are you there, Salah?
Yeah, yeah. I'm sorry, I have to take my siblings out.
No, no, no problem. Okay.
Yeah.
So what
Could you please repeat
actually,
what you said while I was muted? Because I
sorry?
wasn't focused. Could you please repeat what you said when I was muted?
Uh,
Because I didn't hear you. To my siblings, I have to.
Sorry.
Could you please repeat what you were saying? Because I couldn't
I
hear
was
you. You
saying,
were speaking.
yeah, yeah. I was saying that what actually pushes the charge to flow in the circuit? The potential difference provided by battery or some kind of the electric energy source. Like
Yeah.
we say that the charges are flowing in the circuit, that means the current is flowing, and we call it the rate of flow of charges. But actually, what is the thing which uh, motivates or pushes the charge to flow? And that is the potential difference. We will see in the detail in the upcoming topics that what is potential difference. But consider it's a driving force which pushes the charge to flow around the circuit.
Sorry.
Okay,
Yeah.
are you hearing
Yep.
the salah, the call to the prayer,
Pardon?
the call to the prayer?
Um, I'm gonna check on Muslim phone. Oh, I missed Doha.
No problem. We can do it at 6. My Maghrib and yours off.
What time is it for you right now?
It's 5:53,
Okay, okay. No problem.
and we will do 6 Zohar and Maghrib. So Salah, we
Yep.
define velocity that rate of change in displacement,
Mm-hmm.
isn't it?
Yep.
So in the same way, when we define current as the rate of flow of charges, we will write its equation like I is equals to Q over T.
Yeah.
Q is are charges and T is time. It says that how much charges, how many charges are flowing in a second. Okay.
Yeah.
So that is the equation of the current. Okay. And
Mm.
as I told you, the unit of current, it is actually the unit of charge is what?
Oh,
Coulomb.
oh
And
yeah.
unit of time is
Seconds.
second. So it is coulomb per second, which is equals to amperes. What?
Um,
Yes.
amps.
Uh, you call it amps?
Yeah.
Okay, we call it amperes. Okay. So this is the equation we derived.
Mm-hmm.
Okay. If you take t on the left side, it will become, q is equals to I times t. Okay.
Yeah.
So see the problem. Our battery charger passes a current of 2 ampere. Okay, fine. It is current I. We have through a cell over a period of 300 seconds. So it is a time 300 seconds. How much charge is transferred to the cell? How much charge is transferred to
Yeah.
the
So,
cell? So we want charge, which means Q, and that's equal to IT. Okay, so I current they had given us 2,
mm,
and the time is 300 seconds. Okay, so it will become 600. Okay,
yeah.
so 600 watt. What is the unit of charge?
Uh,
Coulomb.
Coolant.
Okay, so we write it.
Was it C? Yeah.
Yeah, yeah. A student creates a simple circuit containing a battery, a switch, and a bulb. She connects them all in a single closed loop. Draw the circuit diagram for this circuit. Do you understand, Salah?
Yeah, but it's telling us to draw it though.
Yeah, they're asking us
What?
to draw. And when we draw, we will use the symbol from this table.
Okay, so you need to choose one.
We need to,
Do we need to choose one from the table to
yeah,
match
yeah,
with
yeah.
what she said? Okay,
Battery,
okay.
switch, and a bulb. We should choose from the table and draw a circuit like this. So battery is symbolized as,
Yeah.
and bulb is symbolized
Yeah.
as, okay. And what is the next? Switch.
Both.
Switch.
Oh,
We use switch is, you see switch. Switch is like this. So switch is like this. And we can open it or close it. Okay.
yeah.
So it is like this. She connects them. So we should close the switch. Okay.
Mhm.
Sure. So it will looks like closed. Okay.
Yeah.
Plus 180 and no. Yes. So we have resistance which is equals to VIR. So this is very important formula. And as I told you, we will see in the detail what is resistance and potential difference. So actually, it was given by a scientist whose name is Ohm. Ohm. So that's why we name it Ohm's law. Ohm's
Okay.
law. Okay, Salah.
Yeah. A question for the resistance in chemistry and physics is different. Right?
Resistance because
I mean the definition of potential different. in physics and chemistry is not the same, right?
Of resistance,
No potential physics
physics and
and
chemistry.
chemistry. Yeah,
What
it's
is the
not the
definition of resistance in chemistry?
no. I said potential,
The
the potential energy.
potential energy.
Yeah.
Uh, Salah, when
Mm-hmm.
we talk about the potential, the word is actually talks about the position change in the energy that we gain energy with the change of position.
Yeah, yeah.
Like this is thing, but we
If
have
you
different kind of potentials,
yeah.
like electrostatic potential, like
Mm-hmm.
the potential difference we see in the chapter, and the gravitational potential when we lift the things up, and the elastic potential when we apply the force of the springs, so it gains the elastic potential. So there are types of the potentials. Okay, Salah.
Yeah.
So it depends on the situation we are dealing with. So now we are dealing electric circuits. So the potential difference is actually uh, the voltage difference between 2 points. Okay.
Mm-hmm.
The current flowing through our components depends on. So Ohm's law actually states that V is proportional to I. Okay.
Yeah.
Do you know what is what is it mean by the proportional, direct proportional?
No.
So Salah means that if one quantity rises, the other quantity will automatically rises, increase.
Yeah.
Like if we because it can be written in this way also. There are two ways. So it says that the more potential difference if you provide to the circuit, the more current will flow. Okay.
Yeah.
Definitely, if you provide the more potential difference to the circuit, so there will be a more flow of current there. Okay.
Yeah.
So that is actually given by the Ohm's law. When we see practically what happens when we provide potential difference to the circuit and the flow of current, we found there is some kind of the resistance there. Actually, Ohm found that there is some kind of a resistance. So when he made the equation, he uses a um, variable for the resistance R. Okay, Salah,
Yeah.
which says that when we provide potential to the circuit, yes, there is a flow of current, but along with some resistance in the circuit, because circuit actually don't want to flow the current. It it shows some opposition to the flow of current.
Okay.
Okay, Salah,
Yeah.
you can read this box. Okay,
Resistance measurement. Yeah.
so it actually the opposition to the flow of current. It opposes,
Mm.
and the more the resistance, the less will be the current, because it has an inverse relation. You can see if I take I on the left side, you see it will looks like this. So now you can Salah, you can relate the resistance and the current. The
Mm.
more current, there will be less resistance. The more resistance, there will be less flow of current.
Yeah.
Okay.
Mm-hmm.
So they have an inverse relation. And when we talk about its unit, you know the unit of potential is volt, and the unit of current is amps. You studied it.
Oh, then do you know what?
Sorry.
What was the second one? Do you know what?
Amps, amperes. This
I'm
one's
says, do you know what? Oh, yeah.
okay. So volt per ampere. So how we pronounce it? Volt per ampere. So that is actually equal to ohms. What?
Oh, yeah.
So this is the symbol of ohm.
Yeah.
So resistance is measured in ohms, and you know current in amps, and potential difference in volts. Okay.
Mm-hmm.
So I think you understand the concept of resistance. The resistance is actually the opposition to the flow of current. The more resistance will causes the less flow of current in the circuit. Okay, Sala?
Mm-hmm.
Yeah. So we have an example. A 4 ohm resistor in a circuit has a potential difference of 6 volt. This is the resistance, which means R, and voltage is represented by V. What is the current? They asking current. From this formula, Sala, if
Mm-hmm.
you need to find the current, the R multiplying here will go on the left side and divide it. Isn't it?
Mm-hmm.
Like this. Am I right? Because they ask current. So they can ask any of the one quantity by providing the other two quantities. We should do that. Can we?
Yeah. We need to switch it up.
Sorry? Yeah.
We need to switch it.
So Sal,
Yeah.
I don't know why they didn't mention the name of the scientist for whom. But are you clear with these things? I'm not going uh, further from here. I will go after the prayer.
Uh,
Salah.
yeah. Can I go pray now?
Yeah.
Oh, that's it. Okay.
Are you clear with these things?
Um. Yeah.
We will
So
start
basically,
from
can you just give me like a summary of what you just said, like a small summary of everything in this topic?
small.
Yes, small summary of everything that we did
Yeah,
in this topic.
we okay, we define the Ohm's law, which states that the potential difference is directly proportional to the current, which means that the more potential difference will give us more current flowing through the circuit. But he
Mhm.
also mentioned that there is some resistance in the circuit which face to the current. Like there is some kind of a resistance in the circuit
Yeah.
which actually opposes the flow of current. So he uh, put R, a variable there, which represents the resistance value. So in
Mhm.
order to find the resistance value, we just divide potential by the current, and we see there is it's equal to the ohm. Okay,
Mhm. Mhm.
so that is actually the resistance. So what is the resistance, Ala?
Resistance is the opposing charge that we need in a circuit.
Flow of current. Yeah. Not charge. Charge
Yeah.
is charge, but current is
Yeah.
flow of charge in the circuit.
Yeah.
Charge is just Q symbol. Yeah, like it's a charge. But when we talk about current, that the flow of charge is actually current. So the greater the resistance, there will be smaller the current flows in the
And
circuit.
the greater the current, the smaller the resistance.
Yes, yes, yes. And we
Okay.
just see the symbol of it and unit of the resistance. Unit of current we know amps, and the potential difference is volts. And I will show you the picture that how potential difference work. Potential difference actually works like this is a mountain, okay?
Mm.
And on this mountain, I I have something on the top of the mountain,
Mhm.
and everything in the top of the mountain will try to flow down when we release. Why? Because here at the bottom of the mountain, there is zero potential. What? Zero potential.
0%.
Yeah, and at this position, we have higher potential. We have higher potential. So, what will happen to the stones which I have at the top of the mountain, Salah?
Mm-hmm.
What will happen to the stones when I release the stone from the top of the mountain?
It's potential, release potential.
The stones will start flowing.
The position effect is potential difference.
Yeah, yeah, the stones will start flowing towards the bottom.
Yeah,
Isn't it?
yeah,
They
because
have high potential.
you let go of the rocks which affected its potential difference.
Sorry, sorry.
Because you let go of the rocks, it affected the positioning and the potential difference of the rock.
Yes. So they have the had the high potential there, and there is a position where zero potential. So it is a natural rule for anything in the world that potential flows from high to low. So the stones have higher potential, they will flow towards the low potential at the bottom. Okay.
Mm-hmm.
So this is the same condition in the current circuits. When we switch on the circuit, the battery have highest potential, like 220 volts, something like you see they are written, or 240. So what happened to the circuit? It has a 240 volt potential at the starting point where we switch on the switch of the circuit, and where we are using, there is zero potential. Like in the laptop, I have no potential in the laptop. My laptop is dead, it has no battery. So when I plug in the switch, you see the switch has two providing me the 240 potential difference with my laptop. So the current will automatically flow from the 240 potential to the zero potential, which is in the laptop. So it automatically flows towards the laptop. So which causes it to flow? The potential difference. Which is flowing? The charges, the electric charges carrying that potential and move towards my laptop and provide energy to it. Okay.
Mm-hmm.
So see you after the video.
Hello.
Yes,
Um,
yes.
I might take a little bit longer because I haven't done wudu yet.
Okay.
Wudu.
Okay. I'm here. No problem. When we talk about ohmic devices, so these are the devices which has constant resistance. So what is mean by the constant resistance? So they would have,
The resistance is not changing.
Yes, their resistance is not changing and has some fixed value. These
Yeah.
are ohmic conductors. We call them ohmic conductors. Have fixed resistance. Okay. So
Yeah.
their voltage current graph looks like this. A straight line. Uh, okay.
Mm-hmm.
So these are known as ohmic conductors. And we say that they obey Ohm law.
Yeah,
Okay.
big what? I'm sorry.
Sorry.
What did it be?
They obey Ohm's law. Ohm's law. This is Ohm's law.
Oh,
They obey it. So what are their physical conditions which actually the scientists told us? The scientists told, Ohm told us the physical conditions are temperature should remain constant for this law, pressure should remain constant, physical conditions should remain constant, like temperature, pressure, humidity, these kind of things. Okay?
mm-hmm.
If these things remain constant, then the device will hold Ohm's law
Yeah.
and have fixed ratio, fixed resistance. Okay?
Yeah.
Okay. So for that, we follow this rule which I told you. Read it.
The current flowing through it is directly proportional to the potential difference across.
Isn't it? Which I told you
Yeah.
there. So that is for ohmic devices, which
Yeah.
has constant resistance and has fixed temperature. Okay.
Yeah.
So when we talk about non-ohmic devices, so Sola, the voltage current graph would look like this. Okay.
Mm-hmm.
Or something like no, not this graph, other than else. You can maybe any graph. Okay.
Mm-hmm.
So these are non-ohmic devices, or non-ohmic conductors, we can say. Non-ohmic conductors. So they do not have constant resistance. They have variable resistance, Salah.
Yeah.
Variable resistance.
Yes.
Why? Because there are some change in these kind of the physical states, mostly in the temperature. Salah,
Mm-hmm.
have you have you touched a bulb, filament bulb after it's 1 hour of working?
Yeah, it becomes really heated.
Yes, that's the point what I want to ask. So their temperature at the start when we just switch on the bulb, filament bulb, so that was
Yeah.
no, but
Yeah.
after some time, its temperature rises. And when its
Yeah.
temperature rises, it will not obey Ohm's law. V is equals to
Yeah.
IR. So it becomes non-ohmic conductor. Non
Yeah. I'll make that.
non-ohmic conductor because of the rise in its temperature. Okay, Sala?
Uh-huh.
So the resistance increases with the increase in temperature. And you
So
know when
when so when will it be an ohmic conductor? Is it when the temperature is low?
uh, temperature fixed, when the temperature is
Oh,
fixed,
so when it starts to rise, it starts to become a non-ohmic.
yes, yes. Rises or decreased in both of the cases. It will become
Oh,
non-ohmic.
alright.
Okay.
Mhm.
For diodes, the resistance depends on the direction. Because here is the symbol of diode. Salah,
Yeah.
can you see it?
Mhm.
This is a symbol of diode. If you use diode in this way in the circuit, the current will flow. If you install it in this way, so the current will not flow. Okay?
Why is that?
There is a long physics behind it. When the diode come, we will discuss in the detail. I will give you a short out of it. Okay?
Mhm.
Listen. So when we install diode in this way with the battery, so it is forward bias, Salah. Forward bias. The symbol is, it is forward bias. The current will flow from this position. We call it forward bias. And when we install it in this way, so the current will not flow because it is reverse bias. Reverse bias. Okay.
Mhm.
So it stops the current. We will see in the detail when the diode topic is comes. What is happening inside the diode. Okay. So there is no physics here about the inside. Okay. Okay, Sala.
Mhm.
So yeah, they're written. Okay. That's the thing which I told you. Okay, Sala.
Yeah.
Okay, so an appliance is connected to a 230 volt source, Sala.
Mhm.
Calculate the resistance, do it on your notebook. If it a current of 5 ampere is flowing through
Our
it.
resistance is mass times, it was 5 times 330.
Resistance is? Oh
5
no.
times.
Let's see, Sala.
Oh, my bad. Yes, it's divided. Divided.
Yes. Okay. So what you get?
I'm gonna go back up.
Sorry?
I'm gonna go back. 1 second. It's 0.03.
Yes, 0.03. View. Very, Sala? No.
Pardon?
Sala, it is V over I. V over I. V over I.
Oh, okay.
V. This is V.
Yeah.
It's what's the answer? Okay.
Can you hear my background noise?
What is?
Can you hear my background noise?
No.
Okay,
So Zoom works perfect.
perfect.
Okay. So have you got this answer?
Yeah.
So what is this, Salah?
230 over 5. Oh, that's the uh is
That's the
that the percent?
ohm. Ohm.
Oh, hold on.
Unit of resistance. Ohm. Okay.
Yeah.
Okay. So you have an assigned task to write a difference between ohmic and non-ohmic devices, conductors. Write the homework list question. This question. Write the differences between ohmic and non-ohmic devices. Okay, Salah?
Yeah.
181. Yes, 182. This is 183. 180. Salah, what is this page number? This is 185.
Okay.
What is this page number?
Um, I don't. Can you me? It doesn't not say on the top. It's 1E.
Do you have book?
Yeah. I'll go get it.
Okay. Where is 182? I don't find it.
I'm gonna go get my book.
Sure, sure. Please keep the book. 180. Where is the 182? 190 molar power. 191. 192. 182. Oh, okay. This is okay. Okay. Investigating resistance.